Hello everyone, and thank you all for joining. My name is Zied, and today I will present you this presentation about building an event-driven generative AI application. So you might say there are a lot of buzzwords here in this title, but I will, I try to convince you that by adopting some of these event-driven architecture patterns and asynchronous workflow patterns, basically this would improve your basic application, and this would help you scale and have an application that is more flexible and more adaptable. And of course, it will be applicable to your generative AI application service or API, if you will. Bonjour. So I'm located here in France, Paris. My name is Zied. I'm AWS community builder since 1 year now, and I currently work as a principal architect at Aviv Group. Aviv is a real estate digital company here in Europe, and we operate many brands here in France, Germany, and Belgium. You can find me blogging. I love talking about serverless, AWS stuff there. So you'll find me on that Medium blog. Let's connect also on LinkedIn and on Twitter. I'm not really active there. I'm more of a lurker, but happy to connect with you. On the agenda today. Basically, on the first part, I will get really quick on the capabilities of generative AI on AWS. It will be a quick overview. There are a lot of awesome talks and deep dive talks on that part. I will want to be really focusing on that. So the idea today is to discuss and to focus more on how to build this AI-powered video summarizer, right? And then how to improve the architecture of that application and how to scale the architecture with EDAs, right? With EDA. And then the last part, I'll describe some of the principles that I generally try to apply when I would like to expose asynchronous APIs or event-driven APIs to the outside world, right? And let's finish with a demo there. Bedrock. What's Amazon Bedrock? So it's a serverless generative AI service from AWS, and basically it's a hub, right, that connects to several partners and leading startup on that space, on the AI space, right? It provides what AWS call, and we generally call, foundational model. So it's a managed foundational model service. And what's a foundational model is large-scale neural network architecture that serves as a basis or a foundation to build AI applications, basically. And it's capable of understanding complex pattern and generate new content based on the data and the patterns that they have been trained on and learned, basically, right? So foundation models are trained on this huge and massive data, and they are also specialized on some features like text summarization, conducting discussion dialogues with users, code generation, code understanding, image generation, etc. Right? And LLMs is part of this foundation model that are focused on text understanding and all of what goes around text and language understanding, right? So Bedrock, one of the nice features of Bedrock is also customizable. So you can adapt some of these foundation models, right, to your own domain-specific problems or your own data sets and use cases. And yes, it's also serverless, so no infrastructure to manage on most cases. And it offers a good integration with AWS landscape. So basically, with Bedrock, you could connect directly with a step function and to invoke a model there without having to write a lot of complicated code there. So on this list, you will find these these partners that Bedrock allows you to connect to, like Jurassic, Claude. This is what we'll be seeing today. Claude, Anthropic Claude, Meta Llama 2, and more recently Mistral, which is a French startup in that space. And so when working with LLMs, there are some challenges there. one of the challenges is the knowledge cutoff, right? So the data basically it's not fresh. So the knowledge cutoff is the date until which the model has been trained with existing information, right? And basically, when you will be using an LLM, interacting with an LLM, you won't be having fresh data there, right? So this is one of the issues. They're also prone to hallucinations sometimes. In some situation, when you engage with let's say ChatGPT or other LLM-powered chatbot, depending on the nature of the discussion that you're having with it, it might hallucinate, right? It might produce some incorrect result. And also, there's this black box, right? Sometimes we do not understand, we can't interpret and understand why an LLM produced that result, why it inferred that result, right? And there are some techniques basically to help improve the output of LLM and to address some of these challenges, right? The prompt engineering, this is one of the most known techniques, right? So the idea is to craft your prompt and to make it work and to guide it, right? To produce the result that you are expecting, right? It could by putting some constraints, some limit when you are building your prompt, defining, for example, I would like to output structured JSON, for example, with that given schema. So some LLMs are able to understand what is a JSON schema, so they will try to provide you a result with the expected format, right? There's also another technique which is retrieval augmented generation. So the previous month there are many talks and discussions around this technique, and the idea here is to allow an LLM to access to fresher data, right? To have access to more up-to-date data. And for example, one of the techniques is to rely or to use some vector database there to do some semantic search before building a prompt and submitting it to an LLM, for example. It could be also done via function calls, for example, right? To let your, let's say, OpenAI to call you, right? When they need to get more information and more insight regarding your initial request. And also model fine-tuning, and the idea here is to adapt the initial model to your own specific use case. Okay. Enters Claude. So you will notice this strike through. So because the talk, when I started creating this talk, it was basically that version 2.1, and yeah, last week AWS announced that today they are offering so Claude 3 is generally available on Bedrock, right? And yeah, so Claude is my opinion is that Claude is a serious alternative to GPT-4, right? Because it's able to so following this benchmark as you see here on the right. So these are published on Claude website, but for me, there are some features that are really interesting here. For example, Claude is able to handle this large context window, so context windows, so 200,000 tokens, which are about 300 pages. And yeah, so it is able to maintain consistency and to produce good results even on a large prompt, right? If we were to summarize a large text, for example, he will produce good results there, right? And also Claude is able to understand code, right, and to generate code. So you could ask Claude to generate, for example, a structured JSON or even code, or even CDK code or TypeScript code or whatever language it's trained on to generate the structured code out correctly, basically, right? And yeah, from Claude 3 also is able to do this, provides these vision capabilities, right, as on Clip, right? So to understand what is happening in an image. So with Sonnet also, Claude is able to provide this. And this is basically what we will be using for our video summarizer. Okay, so let's start. Let's enter the important part of this talk. Okay, how to build this AI-powered video summarizer. So my first attempt when I started working on this video summarizer, so let's just build an API, a simple API. I will provide a YouTube video URL. I would extract a structured JSON out of that video, right? And this JSON I would like to get to identify the presenters, the speakers, the topics of that video, and also an array of containing several sentences of that summary. And also the idea also is to generate audio from that summary, right? So I'm a lazy person, so I would love to hear that summary of a video instead of like spending 1 hour or two watching the whole video. So and basically my first, as here I say, naive approach was to use, as you see, so this is a workflow, right? So I would be using a step function there to do this summarization task. So the first task would be like naively call YouTube to get request a transcript from YouTube, right? And by naive, why? Because YouTube does not provide an official API for that. So it does not work all the time, right? And we'll see later how to fix that issue. And also, the first step is getting the transcript. Next, the idea is to generate that prompt that could help me have the summary from the transcript, right? And basically, what I'm doing here is that I'm creating a lambda that gets the transcript and then generate the prompt and writing into this S3 bucket, and then invoke directly Bedrock through direct integration from with the stamp function, right? And the idea here is I am relying on this bucket to monitor or to have the overall state of my summarization job, basically. And so the last step is just using Poly to generate the audio from the summary, right? As I said, this was the first naive solution. So basically I'm just using a library here that I found it on LangChain documentation, basically, which allows to via an unofficial YouTube API to get the transcript. But so this library is like the last commit dates 1 year ago, and it's like a brittle solution because it does not work on some languages, right? And some on older video, sometimes the transcripts are not there. So this won't work on all situations, right? But let's see afterward how to solve this issue. Just to show you how to craft, for example, a prompt that worked on my use case, so the idea here is there are some things that are really important when prompting with Claude, is that we need to be really clear without any ambiguity, and we do not no rooms for assumption, right? And the idea is to provide a role for your task, right? To let the LLM, okay, what it would be doing. So Claude is trained to understand what is inside this XML tags, right? So here, this is a marker that, okay, pay attention to what is inside this. So you would be summarizing this part, right? So here I will be giving this instruction. But one interesting thing that even you will find it on the documentation of Claude, of Anthropic Claude, is that be straightforward with that. Sometimes we tend to write, please, can you do me this? But basically, by doing this, it gives room for assumption to Claude. And basically, the idea is to be as direct as possible. And also, what is really important here is to define some constraint. Right? Sometimes, so I would like to identify presenters or speakers on my video, but sometimes it will. So Claude won't be able to do that. So it might happen. So when I tried to test first, try this implementation, I tried it first with a reinvent video speaking about lambdas and all the stuff there. And it produced like Jeremy Daly was the speaker of that presentation. It happens, it's not the real case. So because it tried to not invent, but from his knowledge, okay, here is the best speaker that identified for that video. So the idea here is to prevent that, to prevent Claude, sorry for that, to prevent Claude from inventing things, right? And also, which is really nice with Claude is that as he's able to understand the code, the idea here, we want to produce a structured JSON. We want to produce structured format there. So the idea is to provide this JSON schema for the output that we are expecting, right? And this has another advantage, which is my prompt is also maintainable from like developer perspective, as I am having a contract there. I'm having a JSON schema. If I were to evolve this schema, so I know, okay, there is code here. I can make changes. I can version it. I can, which is really interesting here. So another thing to take care of, which is really important, like Claude loves talking, right? And the idea here is to assist it, to pre-fill or to start his answer, because if let's say I ask Claude to generate some random JSON there, right? He will do that, but he will start producing some text before, right? And the idea here is to tell him, no, please, I would like a structured JSON, so you will need to force the assistant. So that's why putting these words on Claude's mouth is that you will start with this opening bracket here to let him produce the rest of the JSON, right? So here's the definition of that step function in CDK. So the most important part is you do have this first part that generates the model parameters, right? Writing that prompt into the bucket. And then, the next step is to invoke the model. So the idea here is to not create an additional Lambda function that would wait for the result, but just a direct invoke. That way, we are not paying that extra wait time for the Lambda function, right? And then the idea here is that we will be making sure that the JSON is well formed. As I explained earlier, is that you will be starting your prompt. You will be telling, okay, Claude, I would like to generate JSON, but he will be he won't generate the complete JSON. There is this missing opening bracket, right? So he will be producing the rest, and you will need basically to add it to your output. I mean, this is not ideal. It works, right? But basically, my task is split into there is a part which is written in Lambda code. There is a part with direct integration with Bedrock, and the other one fixing the format there. So we can do better, I guess. And the last part, which is about audio generation. So here, an overview to what when the step function is deployed. So the first part is generating the model parameters and then invoking the model. And so that step basically would generate something like that. So the speaker that were identified in the video, the topics, and an array of sentences of that summary. But okay, this works. I am happy with that. Some sort of MVP, but can we do better? Yes, of course we can do better. So, and here, basically there is this service which is called Amazon Transcribe that allows me to transcribe videos, right? And here, basically the idea is to use it instead of relying on an unofficial API that sometimes works, sometimes does not work, right? And basically the idea here is to download the video, right? This one, I know that it works, put it into media bucket. And here we'll be using, this is the first step, to rely on an event-based system, right? So with the S3 bucket, basically when you put items, you can subscribe to events there to do some tasks, right? And here my task is to start the transcription job. So I will just tell to Amazon Transcribe, okay, please, I do have this media file. Can you transcribe it, please, right? And then I will tell Transcribe, okay, once you finish, you put it into bucket, right? And then again, I will use that event, object-created event, to start the summarization task, right? So this solution is stable. This works, right? But as I say here in the slide, so it got some important architecture side effects, right? So my system is now no longer synchronous, right? If I were to expose it as a synchronous API, this won't work, right? So my event is now asynchronous event based, right? So I'll need to find a way to expose this workflow, right, to outside consumers, to outside systems, right, as an API. So we'll see later how to do it. Okay, so everything is good. So I know how to summarize my videos. I know how to make things work properly. But can I scale my architecture? What if I would like to add a new task, which is about not summary, but I would like to generate, for example, SEO content out of that video? What if I would like to generate some learning materials, some quizzes, or whatever I want, right? I could, for example, put everything inside that step function. It will work, but at some point it will become this monolith, right? So at some point I will need to find solutions there to scale my architecture, right? And EDA, event-driven architecture, could help in that sense. But generally, when we talk about EDA and distributed systems, there are these two parts that generally discussing about. So orchestration versus choreography, right? So the orchestration, the idea here is to have one central component that manages everything, right? Let's suppose that these different tasks are generative AI tasks, summarization, SEO content generation, all the stuff there. Right, so my orchestrator basically would send commands, would basically control the workflow, right? And I do have it on a central component, which is nice because I know what is happening if I were to observe my system. So I know that my orchestrator could give me something there to view what is happening there. The other way of doing things in a distributed system is a choreography, right? So I would be having several tasks, right? I would be having let's say, several generative AI tasks that are summarization, as I said, audio generation, etc. That will collaborate via events. So the first task runs. Once it finishes, it emits events that is will be consumed by this task. For example, it will start, and then so the system will work based on event. So this is good because my system is now extensible. So I can add a new task. So without having to worry about, okay, what if the overall system breaks, or what about maintenance, etc. But my system is now harder to observe. My system is now harder to I will need to find solutions there to make it easier to control and to observe and to have a proper status of that job, right? And basically, building an API out of this. Let's say I'm exposing some sort of an API to get me a result of my several tasks would be kind of hard, right? So which pattern works best? So let's first try with choreography, right? Because we do have some initial steps there that are fully, let's say, event-based, right? So the first part would be media handling, right? Someone or some process would put medias into my bucket. I will start, So the bucket will be downloaded. Maybe I can start some antivirus process. Maybe it can be long. But once it's finished, there is an event that will be published, which is new media uploaded. Right? This could be consumed by the transcription process. Right? Again, the same thing. So this will fire transcribe. For example, for 50 minutes, it takes transcribe like 3 minutes to transcribe a complete video. So it's the process takes time, right? But it makes sense to have it event based. And once the transcription finishes, so I do have an event which is transcription completed, and I can publish it. This final pattern, and I could start several tasks in parallel, right? So the advantage here is that I could add tasks. They can subscribe, a new task can subscribe to this event, and so I won't impact the entire system, right? But if, for example, this second task that does summarization fails, again, my application won't be impacted. The entire application will work, basically, right? But again, I would like to collect all these data, have something meaningful to expose as an API, right? Enters this gather pattern. And on this pattern, basically, I will have an additional component, right, which is an aggregator that would subscribe to the events that will be emitted from these different tasks. When a task completes, when a task fails, when there is any, let's say, a heartbeat, for example, you could use that also as events to let know the aggregator that everything is working fine, for example, on this summarization task, for example, right? And the aggregator basically would collect all of these events and decides what kind of event it would expose to the outside world, right? As an example of implementation here, transcription completed could be published through an SNS topic, for example. It will trigger, so several tasks will subscribe to this event. They will start, for example, the first task I could implement it with a step function. The second task I could just a lambda function. It might happen that I do have, let's say, a recommendation system that is maintained and run by another team, right? It's owned by another context. So it makes sense in a way to have this kind of a way of interacting with events, right? And here I would be collecting the output of these several tasks, right? And the aggregator basically would subscribe to these events, would write the results here into, let's say, as an example, a DynamoDB table. And I will have a lambda that would understand what is happening via DynamoDB stream, for example, would derive proper events that would expose to interested subscribers. This can get tricky there, right? Because, for example, this architecture would work for an unbounded stream of events. But what if I do have an API that I do have a client that waits for a complete answer? What if one of the tasks fails? How should the aggregator behave? How should the aggregator determine that, okay, there was an issue and now the overall task is completed, right? And so this is nice, but as I said, the aggregator pattern could be hard to take, basically. If I do have a task that fails, if I do have a task that never produces an event, I do have a technical issue here and I never get a result back, right? How to monitor the overall progress of a given job, right? How to make sure that my system is observed. So there are a set of challenges here that I need to address when adopting this pattern, right? And so orchestration or choreography. So what kind of choreography might be complicated. So should I only stay with orchestration? I mean, we can do both, right? And on that, for example, as a solution here, it can be improved, right? What I can do, so I could have a process that monitors the state of the job, right? It can act as somehow like an aggregator, right? It collects events from different actors. It can decide on, okay, given these events I am receiving, I can decide on the job state, right? It can also handle timeouts. For example, let's say if we define for a given job, the max timeout is for 1 hour, 2 hours, 5 minutes. So this part could decide of the overall state of the job. And so we could also use that function. We could also use orchestration on some part of my system, right? Here, for example, for my several tasks that are doing this generative AI task, right? Summarization, generating quizzes, generating audio, for example, we could use that function there, which is really good service and capable service to do that in an elegant way and an easy way, right? And here, for example, as an example, let's say I do have this task that is that is owned by another context, right? Here with that function, we could use, for example, the wait for callback pattern, right? So I can start a task and I wait for a result that could be produced later on in the future, right? And then everything is met here, and I could publish this final event, right? And yeah, so I've built my system. I'm happy with it, but now I would like to expose it as an API. So there are some principles there I would like to share them with you. So one of this code, generally, I think of this code every day when I try to expose API publicly. So APIs are like Diamond are forever. Right? So this code is from 2006 from Joshua Blanche. So he wrote a set of principles there to design APIs, and this one is always something that I tend to respect all the time when designing APIs, right? To expose API to the outside world. But generally, I also tend to apply these principles, right? One of the principles that I try to apply always is that to be conservative on what you send. So this is related to the Posters law. So when you're designing your API, what are you producing to the outside world? Try to be conservative. Try to expose the less data as possible, right? Why? Because if at some point your API evolves, you will be having less problem dealing with versions, for example, right? Dealing with versioning and how to negotiate with your consumers, etc. When your API evolves, right? And you decide, and for example, if you decide that you would like to change a type of a field, for example, by having a short and concise contract there, it will be really helpful there. The other principle that I also try to apply is related to the observed behavior of an API. Right? At some point, you can decide that, okay, my API is asynchronous. Let me try to produce some heartbeats, for example. Let me try to produce some intermediate events that I'm sending to my consumers. But at some point, you decide that, okay, my system works fine. I no longer need these heartbeat events, for example, or these events I'm sending while my job is running, right? This could impact your consumers, right? Because they might rely on this observed behavior of your system, right? Another principle is about making clear distinction, making clear separation between your private event that is running privately and what you are exposing to the public, which is somehow related to the first principle. So the next principle is about versioning strategy, right? And the idea here is to adopt the same strategy, right? It might be hard at first when you are designing your API, so your contract will be evolving, will be changing frequently, right? But at some point they will be stable in time. So, and the idea here is to define what is your versioning strategy. What is the, let's say, deprecation of older version of your API? Should you accept or should you manage breaking changes, for example? Or so this one are really important question to ask yourself when designing APIs, right? Even for event-driven APIs, of course. And also the other part is adopt standards there. If you were to expose API publicly, here generally I tend to adopt these standards like cloud events for defining model. So cloud events is a specification that defines how your events are, the shape of your events, right? The model of your events. And I think API is more of specification to describe and like open API when you are exposing like open API, when you would be exposing your API. So I think API is something like that, a specification that helps you describe and document your API basically. All right, so putting everything together, so if you were to build this generative video summarizer. So here I do have my system, right? Which is here, which is event-driven, that works, right? And here, which is really important, is to make clear distinction between your API service, right? So the API surface level and what is inside your system, what is running inside your system. And basically here, as an example, I am using an event bridge to publish these public events, right? And yeah, depending on the use case, you might want to build some adapters here to do some technical mapping, right? For example, here these events, for example, could be consumed by another team that is hosting their application on another account. So they're listening straight to my public events. But here, for example, I can adapt my event to conform to what Momento webhook, for example, is expecting. Or here, for example, my adapter would be mapping this public event to more to a format that works for let's say if I'm exposing this as a webhook, for example, as a WebSocket, for example, right? Which is really important here. So demo time, I can show you an example of the application. I build a small application to highlight how this works. So I do have this application that can summarize video, audio, and the YouTube video. So I will be using this feature. And yeah, let me just open the video to show you. So this one is from the last the event of the last year.
Today, I'm Michael Hildebrandt, Distinguished Solution Architect with Elastic.
On RAG and semantic search. Sorry. And yeah. And yeah, so the system, when I define this YouTube video as an input, so it will start transcription process, right? It's really fast because I do a first step. Okay, if the transcription is already available on YouTube, so get the transcription. If it's not available, do your own transcription job with transcribe, right? And then I will start the summary process. So here the application was the service was able to understand what is happening with that video, right, out of that transcription. So the main topics of that video, the presenters, right, and a couple, hopefully 10 sentences that summarize the video, right? And here also by using Amazon Poly, I'm not sure if I am sharing the sound, but here
Michael introduces the topic of making semantic search and retrieval augmented generation, RAG, real-to-build production-ready applications.
Et voilà. So thank you all for your attention. If you have any questions, so.
That was great. You tackled like all the buzzwords, right? That's what.
Yeah.
That's what my upline wants to hear. That's like, oh, GenAI, APIs, event-based systems. It's a pretty cool. It would be nice to run once this is available on YouTube. Run it through your summarization tool.
Yeah. I will try it. I never tried, but yeah, definitely could be a good idea there.
So I know you mentioned on the gather part, right? The aggregator, the failures, right? That was the question I had, right? It's like, well, how will you handle the failures, right? Or process them? Do you have any ideas or anything you've applied to handle those failures for one task, two tasks in the aggregator?
Yeah, on that, like if you are building, let's say, a happy path for scatter gather pattern, right? Again, as I said, so some tasks might fail, right? It could be a transient error there by, let's say, when invoking Bedrock, for example, could be another error happening and whatnot. So here, the problem with by default, if any task is not able to provide like events, like the task is on error state, for example, or the task is not able to complete, etc. So the aggregator won't be able to decide, okay, there is an error, I need to, the job is done, I need just to produce an event here. And basically here, one of the things is that your task, for example, need to be resilient, right? So here, for example, on the first one, I'm using a step function. I could create a failure state, right? Like some sort of a try and catch all. And if something happened in that state, I could produce an event which is a tasking error or task error there, and which would be catched by the aggregator, right? But the thing is, again, what if a task never never produce an event? What should I do then? And this is where, as a solution, this could be like having an overall monitor there that could have an overall view on what is happening in my system, and and to decide that, okay, now there is an error that is happening. I need to just stop this job and just produce the final event there.
Cool. Yeah, we always want to have things not fail on us, right? But they always do.
They always do, exactly.
So, and for me, it's tough usually, right? I always go orchestration, right? I'm just going to use a step function and coordinate all the tasks. And it's like, well, but doing the choreography really provides a lot of value. Do you have any sort of rules of when you consider orchestrated events versus or graph versus orchestrated?
For me, what is really my rule of thumb there, but it depends, right? What is happening inside? Let's like talk DDD and bounded context, right? What is happening inside the bounded context? Generally, orchestration works best there, right? You own that system. You inside bounded context, you can own. Let me just share this part. You can own that centralized component. You are in control, right? So it makes sense to have orchestration inside the bounded context, right? But in some situation, it's not possible because you might rely on a purely asynchronous system, like what we see with like media upload, waiting for media upload or transcription jobs, right? But and choreography, basically, I tend to use them to have the choreography system between like the bounded context, right? And this is generally the rule I try to apply when applicable, right? So
yeah, it's more loosely coupled once it's choreographed for sure. You're talking a little bit about async API and cloud events. So these are two different kinds of specs, I guess. I've heard of async API. I haven't heard a lot about the cloud events one. And you briefly went through the differences, but can you tell me a little bit more about these?
Yeah, sure. These are, because generally we tend to say, okay, async API is a competing spec. So they are not competing specs. Cloud event and async API are not at all competing specs. So cloud events a specification for your event models, right? It dictates, okay, your event should have an ID, a type, a date, a data field contains the event payload, right? And async API help you document your API, right? Which is the analogy here is that async API is like open API, right? So how to expose your APIs there and to document them. And what is really good, so they work very well together, right? And these two ecosystems, so these two specifications, they provide. There are some tools that are built by the community there. For example, for async API, you will be able to generate code that is able to parse events that are coming right out of the specification that of the API that you are consuming, for example, and also for cloud events. So cloud events are all libraries that are able to create these bindings for back to publish event via WebSockets, for example, or via HTTP, or
Do you know of any native integrations with AWS yet on these? Right, and like OpenAPI, there's a direct integration and API gateway. Is there any of these yet on AWS?
Yeah.
Any cool integration?
On that, if I'm not wrong, I mean, on that, there is no native integration yet. If we take the example of Event Bridge, there is we need to build a mapper there. We need to wrap, because on Event Bridge there is this detail event envelope, right? And you need to put that cloud event envelope inside the detail. So there is still no native integration with cloud events, but there is a new blog post that was published just now about how to use. It was shared, I believe, on Serverless Discord, on how to use publish cloud events.
By David, the one he just shared.
Exactly. Yeah.
He's big on async API, so maybe now that he's in AWS, he'll get us some good stuff, some good integration there.
Just on that, from the don't quote me on this AWS perspective, but the if there is interesting cloud events, then let Dave know, because it's something that we've been asked for quite a few times from customers. So if it is, Dave's actively collecting feedback on that as well. So I think it'd be very cool to have cloud event support. So yeah.
I think that we will be having a talk in 2 weeks about cloud events from Omid, I guess. Yeah. We'll be presenting some awesome stuff around cloud events.
Some more event-based goodness.
Nice.
Cool.
So just to let you know, so if you are curious to have a look to the source code, just having I have the code published here on my GitHub. Can share it in the chat. So I have the Zoom toolbar that is following me, but which is here.
And we can share this as well in the kind of the discussions and the Believe in Serverless or the CFP, right? We put the video and all that there.
And
any other things you want to include there, for sure. Appreciate that.
Of course. So what you will be finding on GitHub is the naive solution. Right, it's not the complete event-driven solution there, but I'm still working on it.
But it's a good start, right? So even for me, I consider myself an infant in the Gen AI space, right? So having something tangible I can just deploy into my account and play around with is very useful.
I had a question. I haven't done a lot with Bedrock yet, admittedly, but I'm curious for your opinion on latency and regarding the different models. Have you noticed that some models are faster than others?
I honestly didn't test all the models there. I started with Titan model from Amazon. Let me just share not this slide.
Yeah, it's the GPT-4 Claude. Yeah.
Yeah, so I tested first with Titan. Titan was providing good response time there, but I was somehow limited with the context window, right? And that's why I chose Claude there for this summarization system. And so a video having 45 minutes video takes about 20 seconds to summarize, basically, right? So out of transcript, right? I'm not sure how many words I do have on the transcript, but it takes about 20 seconds to get the stuff. It's pretty fast. It's not as fast to expose through an API gateway and to hit that timeout limit, all the stuff there, but it works, right?
Yeah, you got to go async with this.
Yeah, that's pretty impressive, though, regardless. So thank you.
Yeah, and even on Bedrock 3, they were announcing, because you can even request 1 million token per. So this is kind of crazy, but for customer need to ask to have that to have this quota alleviated.
Do you know how long? I mean, I don't know when version 3 of Claude was kind of available. Do you know how long did it take for Bedrock to make it available within it?
And on that, I don't know, but it took me to update my system from 2.1 to 3 took me 5 seconds to redeploy, to change the parameter. And yeah, so but I'm not sure how, when it was, because it was announced last week on AWS, but I'm not sure if it was announced before on Anthropic's side. Yeah.
Around the Gen AI stuff, do you have any recommendations? I mean, you provided a lot, right? But how did you learn to, hey, let me provide the curly bracket so that it gives the format I need and all those things, or just by practice and trial and error?
Yeah.
If you have questions there.
On that, I honestly spent like 1 hour understanding what is happening, because when I built my prompt, right, created my prompt, I started parsing this. I created the parser and to just extract the JSON. It worked, but at some point I was not reading Anthropic's documentation, and it was like written into the documentation. You should do this to make stuff works, basically, and so it was documented, but I didn't read the doc. So.
The normal recommendation: read the docs. Read the docs.
Exactly.
And you said to not be thankful. So, well, when they rise up, will they not attack me if I'm not thankful?
Vengeance. They will try to.
I'll do it without saying that, but it's like, oh, hey, thank you. Remember me.
I say it once. But this one, I was kind of surprised. There were even papers on that. So because I generally tend to, like I speak to a human, right? Please do me this. Please try this. But again, so there's this black box behavior, right? Sometimes we do not understand what is happening really in some situations, right? And maybe this could influence the way how LLM work.
Cool. Yeah, I struggle with like Alexa and with my kids. It's like, well, I want to say thank you, right? Because then I don't want to teach them to just give orders.
Yeah.
Cool. Good presentation.
Thank you.
Insightful.
It was, I had fun building this, and I had fun also working on the presentation. So
I'll let you know in the video we can push it through your pipeline.
Yeah, fantastic. Okay, this is good exercise there. So okay, I will do it.
Any other questions? Anybody? I think we're good. So just lining up next week, we have Matt Martz. Your AWS account is talking. Time to listen. So make sure to sign up, register so you can get the link. And hope to see everyone there next week. Appreciate your time. Zied. I always want to say Zied. It's Zied.
It's correct. It's Zied, yes. Sorry, it's correct.
Thanks a lot.
So thank you all. Thank you all for